It's okay. Okay, so today is a culminating class. We've learned about lots of different kinds of functions this semester, and each of those functions can be used to model real-world things. So we're going to be looking at some real-world data and trying to make a function fit it. Like what function has that shape, and then come up with a formula for it. So this is just the general process for using your TI to do regression. We've done it several times, but it's just rewritten here in case you need to refer to it during class. Words to live by when you're modeling. The more data you have, the better. A model with very little data is not very reliable. If there's a theory-based reason to use a certain kind of function, quadratics for projectile motion, for example, because Newton proved that quadratic is the way these things work, right? So it would make sense to use a quadratic function. A simple model that fits the data reasonably well is preferable to a complex model that fits it only a little bit better. So if your R value or your R squared value only goes up by 100th or 1,000th, you might as well just go with the simpler model and make your life easier. Generally, using models to interpolate, which means finding or making predictions between known data points, is much more accurate than using a model to extrapolate, which is making predictions outside of your data set. When you're deciding on a type of function to use for modeling, it's not always clear from the scatter plot what sort of function might best fit the data. So some suggestions: try a couple of different ones. Just have your calculator do the regression for a couple of different models. You'll probably be able to narrow it down to at least 2 or 3. Then do all of them. Do all of the ones that you think might work, and then use the correlation coefficient to help you choose. And like I said before, if your R squared only changes a little tiny bit, you can go with the simpler model. If R squared doesn't appear on your calculator, these are some directions how to make sure that it shows up, or I can help you if you need it. And here are just some pictures to help you sort of guide you in deciding what kind of function to choose when you're looking at data. So if your points fall in a linear fashion, you do linreg, linear regression. The U is classic quadratic. If you have more than one turning point, cubic, right? 2 turning points, cubic. 3 turning points, quartic, right? The more turning points, the higher the degree you're going to need for a polynomial. And then exponential is that sort of like really fast increase or decrease. And here's where you might have trouble deciding. This could also be quadratic, and we're just not seeing the other half, right? So this is where you have to do a little bit of it's a little bit of an art and a science, right? Logarithmic, slow increase. And logistic has the classic shape for logistic is an S-shaped curve. It increases fast at first and then levels off. So I have some data for you to play around with, create some scatter plots, come up with some models, and I gave some answers, but know that you may have found another function that is also a good model, and that's totally okay. These are like just my opinion. Okay.